Welcome, welcome. This is your MN14 notes about the Pythagorean theorem, section 7.1. Before I actually get into the Pythagorean theorem, I just want to focus on a right triangle. Up here in the top left-hand side, you'll see we have a right triangle with side lengths 3, 4, and 5. Each one of those side lengths we extended out to create a square. And when you create a square, that means if this side length is 3, this side length is 3, and that gives you an area inside the square of 9. I did the same for the other 3 sides, and there's this cool pattern that happens where the square off of one of the shorter legs is going to be 16. If you add that to the area of the square of the other shorter leg, it's going to give you 9, and that's going to equal the square of the longest leg, which in a right triangle is called the hypotenuse, which is 25. So 16 plus 9 equals 25. So again, all that's happening here is that if you take each one of those lengths and create a square off of each one of those sides, the two legs squares will equal, the sum of those two squares will equal the area of the hypotenuse squared. So off to the right here, we have a diagram very similar. Again, we have a right triangle. And using that same idea, for instance, this length is B. That means that this length right here is also B. So that means that this area inside the square is B squared. This length is C. This is C. So this is going to give you an area of C squared. This last one, A and A, is going to give you an area of A squared. So following the pattern that we saw on that left-hand side, I can take that area, A squared, add it to the area of the B squared, and that gives you the area of your hypotenuse squared, which is C squared. And that, my fine young ladies and gentlemen, are, or is, the Pythagorean theorem. Now let me just kind of define it a little bit clearer down here. Before I do want to make sure you know, again, that this is a leg which is adjacent to that 90-degree angle, which means that it is right next to or shares the vertex of that 90-degree angle. This here is a leg, and this is the hypotenuse, which is always right across from that 90-degree angle, and that's important to know where that is at all times. Now, once we have, you know, what each thing is, a leg, hypotenuse, from there I'm going to say that each of the legs we're going to letter as A and B. You could revert those. You can say B, A, it doesn't really matter. But what is important is that we say this, the hypotenuse, is the C. So again, the Pythagorean theorem, which works for all right triangles, so for any right triangle, you can use the square of the A, which is the area of that square off of that leg of A, plus B squared equals C squared. Very powerful tool, actually quite simple in understanding, but you'll see that as we move on, we use it in a lot of different ways. Example 1, it says find the length of a hypotenuse of a right triangle with legs 8 centimeters and 6 centimeters. The first thing I'm going to say, folks, is you're going to draw a diagram. I'm not going to think too much about it, but I'm going to draw a right triangle. I'm going to put the right angle in there, so right away I know directly across this is the hypotenuse. And this is going to be a leg, and this is a leg. So from there, I'm going to go up and look at that, the wording. It says, find the length of the hypotenuse. So this is what I want to find. So that simply means I don't have it. So I'm going to actually put, you could put X there if you want to use X, Y. You can use H for hypotenuse. I'm going to go with a nice, safe letter C. And it does say we have a right triangle, so that's important because otherwise the Pythagorean theorem just wouldn't be a tool we could even use. And then it says legs of 8 centimeters. I'm going to put the 8 centimeters here. I could have put it on the other one. It doesn't matter. This is just a picture for myself. And this here will be 6 centimeters. So then, once I have my labeled diagram, then I can use the Pythagorean theorem. I'm going to always start with the theorem itself, so I have that in place. And now I'm going to substitute what I know in. So my legs are 8 and 6. So I'm going to say my A is 8 squared. I could have said 6 squared. It's not going to make a difference. Oops. The only one that makes a difference really is this, well, is the hypotenuse. So 8 squared plus 6 squared equals c squared. So to solve this, we're going to take the square of 8, which is 64, the square of 6, which is 36, combine those two, which is going to give you 100. And then to undo this square right here, the only way we can undo a square is by taking the square root. So I'm going to write this equation again. And then just to make sure we really see it, I'm going to take the square root of that c squared. What that does is the square and square root undo each other, so that's gone. And then what we do to one side of the equation, we always do to the other. So the answer, so the answer here is going to be square root of 100, which is 10 centimeters, is what letter C is. So we found that the hypotenuse is 10 centimeters in this case. Okay. So let's go on to the next problem. So in this example 1, just kind of keep note that really we were given two sides of a right triangle, both of them were legs, and we had to find the hypotenuse. This next example is going to be a little different in the sense that you're probably going to be given different information. So it says a 16-foot ladder rests against the side of a house. The base of the ladder is 4 feet away. How high above the ground is the top of the ladder? Draw a diagram with labels first. So, you know, whenever I see a story problem like this, I'm thinking to myself, hey, I can draw a picture. So I'm going to draw myself a nice little house. Okay, here I am. I'm going to be in the window smiling because we're doing math. Here's my door that is not proportionally correct, but whatever. And I'm going to draw a ladder because I have to clean the gutters. Putting that ladder up there. And so here's my picture. Now what you have to think about is where is the 90-degree angle, because really it has to be a right angle or right triangle in order to use the Pythagorean theorem. And if the house is in fact plumb with the ground, assuming the ground is level, we're going to say our right angle is right there. Now we have a couple pieces of information. We have a 6-foot ladder, and we have that the base of the ladder is 4 feet away from the base, or the base of the ladder is 4 feet away. So let's figure out where that 16 feet goes. If it's the ladder, and this is the ladder right here against the house, I'm going to say that this ladder is the 6 feet, or it's 6 foot long. The ladder is 4 feet away from the house. That is from here to here, which is 4 feet away. Then from there, it's asking you how high above the ground is the top of the ladder. Well, the ground to the ladder is going to be what we need to find, and that's h. So here again, we have a right triangle. We have 2 of 3 sides. In this case, though, we have a leg and a hypotenuse, and we need to find the other leg. And so we're going to set up the Pythagorean theorem. Let me switch back to blue here. We have a squared plus b squared equals c squared. My one side is 4 squared plus my other side, or my other leg, excuse me, is h. We don't know it, so we're putting that variable in there. So that's the variable I chose. And the hypotenuse is 16, so I'm going to put 16 in for c. And it is so important to remember that that c value is the hypotenuse. That is the one that matters, making sure your placement is right. Now we solve it. So we have 4 squared, which is 4 times 4, gives you 16, plus h squared equals 16 times 16, which is going to give me, what is it, 256. I always forget this one. I solve for h, which means I need to get everything away from that variable by undoing it. So I'm going to first subtract my 16 from both sides. So I have h squared equals 240. And now, as I mentioned earlier, to undo a square, you have to square root both sides of an equation. So to get rid of the square on this h, I need to square root. What I do to one side, I'm going to do to the other. So I end up with the height of my ladder, and you take the square root of 240, round it to the nearest tenth, and you should end up with 15.5 feet. Make sure you do that on your own to make sure that you know how to use that square root button in your calculator. It's easy to not know. Every calculator is a little different. So the height of the ladder against the wall of the house is going to be 15.5 feet up. So again, this is an example of where you're given, in a right triangle, a hypotenuse and a leg, and you have to find the other leg. This example 3 is just a little bit different than the other two examples, and it's actually definitely more dimensional. It has multiple steps here. It says find the area, so this is the first time we're saying area, of an isosceles triangle with sides lengths 10, 13, and 13 meters. So before we can even do anything, we need to make sure we understand this is a triangle, and to find the area of a triangle, this is a flash from the past, I'm sure, for many of you. It's base times height divided by 2, or if you're old school and you go 1/2 length times width, or 1/2 base times height, it's all the same thing. This is how I do it, base times height divided by 2. Now, an isosceles triangle is going to be a triangle, and again, this is kind of a flash from the past, is a triangle where you have 2 equal side lengths. If all 3 sides equal, then it's an equilateral triangle. If no sides equal, we call it an scalene triangle. But this is an isosceles triangle where 2 sides are congruent. So we have 10, 13, 13 meters, and you kind of know where things go only because you have 2 of the 13 meters. So those go on the sides that are equal. And then the 10 meters goes at the base. Now this is where you need to take a step back and look. So if you have area of a triangle as base times height divided by 2, really you need 2 pieces of information to answer this question. You need a base, which in this case is 10 meters, it's given to us, which we love, that kind of thing. The height is not 13. I just want to say that. That's the first thing everyone always wants to say. It's not 13 because that's a slant. Slanty height if you want to think of it that way, or it's a pitch of a roof if you want to look at it that way. A height is going to go from the peak or the top vertex all the way down at a 90-degree angle. So that right there, ladies and gents, is your height, which is a problem because we clearly don't have the height of this triangle. So that we need to find. So here's what I'm going to propose. This diagram's getting all kind of clustered and everything, so I'm going to shade in this triangle on the right-hand side, and I'm going to redraw it over here so it's a little bit easier to see. This is my right angle right there. This is 13 meters. This we don't know. That's what we want to find, which is the height of the triangle. And this is not 10. Remember, we're taking the height, bringing it down. Since it's symmetric, it's an isosceles triangle, that 10 meters is cut in half, so this base of this triangle is actually 5 meters. So that's kind of something you want to keep an eye out for. So now we have a right triangle with 2 of 3 sides, which is great because then we can use our tool, Pythagorean theorem. So we have a squared plus b squared equals c squared. My one leg, I'm going to say, is h squared. My other leg is 5 squared. But most importantly, there's the hypotenuse right here. So if the hypotenuse is 13, that's going in for c, so 13 squared. So we have, when we solve for h, we have h squared plus 25 equals 13 times 13, which is going to be 169. Subtract 25 from both sides, we get h squared equals 144. Now we take the square root of both sides of that equation to solve for h. We get h is equal to 12. So that is the height of that triangle. So coming back up here, we have that the base is 10 meters, so check, we're good there. The height was what we were missing, and now we know that that is 12 meters. So we're good and ready to go on to find that area. So I'm going to do that right here. It says step 3, find the area. I'm going to start with the area of the triangle is equal to base times height divided by 2. The base as we said above, was 10 meters. Now don't use the 5 because that would only give you the base of half of the triangle, not the full triangle that we want to find the area of. The height is 12 divided by 2, and that is going to give us an area of 60 meters squared. I love this problem. It has a lot of different information in it. So I hope this was helpful to you. Thank you for tuning in.